Hello, and welcome back to the Event Modeling and Event Sourcing podcast with your hosts, Martin and Adam. Hello, Martin.
Hello, Adam. Nice to be back again.
Yes, always good to reflect. I know we're both busy trying to schedule the next workshops and all of that. Nicely getting caught up on all the backlog of episodes, but we're nearly there. So some people have probably listened to a couple of episodes in a very short interval.
I've heard from a few people who binge watched all of them in one go.
Okay, well, that's good. I'm glad we're good enough for Netflix-like viewing. And binge watch all of them. But maybe that's good. Maybe we are a little bit not self-aware enough anymore that all the things that we take for granted or common knowledge is not common knowledge to people that are just starting out. So
yeah,
I certainly binge watched a lot of Linux podcasts when I started to move 100% to Linux, because there was so much to learn. And the only way to really learn is to immerse yourself in the subject. Like both of us actually did that for Git, I think, when Git came out. I immersed myself. I don't think there was enough podcasts though, right?
No, there was no information. It was really hard to get information. I even looked at the code. How does this thing work? I wanted to know.
Yeah, same here. And I forced my immersion into the Git subject by answering Git questions on Stack Overflow, which now is redundant because there's no more Stack Overflow because AI has replaced it. But
yeah,
but
I even wrote a book back then about Git. I wrote a book when I finally understood how this thing really worked. When I finally really understood it, I wrote a book. Guess what? I did the very same thing for event modeling.
Yeah, that's so. I mean, it's strange. I forget who said that, but it really works in tech. Is to, if you want to learn something, teach it or answer questions about it. Don't teach it, but answer questions about it, because it'll force you to go and find the source, and more importantly, to understand what you're saying, because you don't want to answer something and be ignorant about what you're answering. And so, to me, that was a way to, while something was compiling, I was waiting, or I was in a meeting during my freelancing days, I would be on Stack Overflow, and I'd be refreshing the Git subject with F5, right? If there's a new question, I would immediately answer it with what it was a popularity contest, right? That Stack Overflow. So my way of getting in as the accepted answer was to, the minute I saw the question, I would answer it immediately with one sentence and hit publish. And then I would immediately go to edit, and I would start adding more. As soon as I got a paragraph, I would save the edit. And then once I'm done that, I'd hit edit again, and I would find examples. I would make the examples for how to use the command or whatever, and explain the different options. And then the third time, I would then publish that. And so usually that would work because someone would have been stuck at least reading your answer. And then when they would go back or refresh their own question, they would see an updated version of my answer, but they were already reading it, right? And so that was crazy. I know. So the number one Stack, you know who the number one Stack Overflow answer person was?
No.
Okay. You can look on there's a global ranking of Stack Overflow users that now is irrelevant because the number one person is AI. But but before it was John Skeet, guy from the UK, and I saw him at one of the conferences. He's the number one spot, and I think so. I forget if it was me or someone else saw him at a conference, and he's in the lineup for food at lunch, and he has a laptop in his palm as he's standing in line hitting F5.
Really?
He lived and breathed Stack Overflow, right? I don't know how true that story is. That's what I hear, but I think he's not a man. He's a machine, because he was able to do his regular work and keep the number one spot on Stack Overflow forever. I mean, there is a point of of getting a velocity because you have enough answers that you covered 80% of the most common topics on a subject. And then people that are asking or searching Stack Overflow, they upvote your answer and all that. So you're passively collecting votes after a while. And so I hit that mark after a couple of years with Git. And then and certain tags get highlighted. So I think the version control tag, as I talked about, not just Git, but problems with other version control systems and how to do. I suffered enough under Subversion and under Visual Source Safe that the common tag for version control, I ended up being like the second one in the world for it, which was kind of cool. Just that's because amazing. So you kind of can look at your performance per tag or your overall performance. I think I was at one point around 800, number 800 in the world, which is pretty good for Stack Overflow. But that took like a significant nonstop effort for 2 years of answering Git questions, like living and breathing Git. So
which made you an expert, right? I mean, it's not just answering questions. This is what makes you an expert.
Being able to solve problems for so many people, so like daily.
And I mean, if you get the questions you cannot answer, the first thing you do is you figure out, okay, what is the answer, which makes you even more an expert.
But it makes you dig deeper because you have to have the deeper your understanding of a subject, the further, the more questions you can answer that are related to the original one. And you can, it's not an effort to type out the answer anymore. This is one of the reasons that, let's close this subject off and go to the next one because, like this binge watching of our podcast kind of puts you into the mindset of people that are successful with event modeling. If you want to be successful at event modeling, look at people that have been successful with event modeling for many years and understand how they think, how they approach a problem. When someone asks me about, hey, what's your opinion on SQL, right? And I can kind of see, in this case, I agree with Uncle Bob, like we talked about, in a previous episode. But it's this kind of like, how do you what filters do you put on for talking about certain pieces of information? How do you relate subjects? And once you understand these fundamental, deeper levels of thinking about something, then you can more naturally arrive at the same conclusion. So binge watching stuff like that, or going, I would say that I was obsessive about Git. I was an obsessive behavior. I was addicted. I remember my commute home on the bus, and I'd have the laptop in my lap, and I'd be tethered to my phone for the internet, and I'd be hitting, F5 on the entire commute and answering questions on Git. I lived and breathed that. Any kind of, instead of like doom scrolling, how they doom scroll on phones for like distracted stuff. That was my doom scrolling. So if you want to learn something really well, I guess replace your doom scrolling with what you're passionate about finding out and just immerse yourself there, and you'll be rewarded. So
I mean, you just have to go to the Discord and answer the questions. There are questions all the time. So typically, I'm the one answering, you're the one answering, but anybody can answer. So
and we do have people answering there. There's a few people that come in and do that, and I mean, we want to be obviously conscious of other people's time commitments. We can't all be free for this type of work all the time. So a lot of people don't have the luxury to have all this time, and that's fine. I mean, it's what time you find that you can afford. If you're going to spend, watching a stupid show for 3 hours, it's your choice. You can watch, some episodes like this, or read other articles on event modeling or event sourcing, and keep thinking about that. But one of the nice things about, I'll use Git as an example, going at a deeper level, you start to become, it's kind of like your life stages. Like you're first a toddler and you're just copying what your parents do, right? And then you go into your 20s, and then you start to explore, and then you find a few good things and you make your career. The same thing happens on a much shorter scale with different subjects. Like, oh,
Yeah.
I just found out about Git. Well, you go and you copy, you find what others are doing, you just copy. And then you start to answer questions, you start to explore possibilities, and you find differences. So that's just how I found, branch per feature. It's like I dug deep to like, okay, what makes this really large source code repository for the Linux kernel scale globally. And I saw, these, how why are there release candidates? Why is there this hierarchy of people, promoting changes and patches and all that? And then if this was all done by email, how is now Git doing the same thing? It's kind of how we talk in event sourcing. How do we do things on pen and paper to understand how we do things in event sourcing, right? So how did the entire Linux kernel work over patches sent by email? It's like, oh, who would ever send patches by email? That's like, oh, such bad work. But it's a fundamental exchange of information that made this happen. Just like we say, oh, why would anyone do a paper-based business these days? Like, you're so inefficient. This is such a stupid idea. But it's not. The exercise is not stupid because it forces you with being very manual. It forces you to understand the need for the efficiency that you need to embody once you automate. And so for me, that was an important thing to go back and see, well, how did these things work by sending email patches by email to all these, from all these contributors to these people that were maintainers to keep such a huge project going. And then now, once you understand that, then you understand why Git was built the way it was. And so anyway, that's just some interesting thoughts on why we exercise our thoughts. But I ended up kind of going down that rabbit hole of understanding why, and that's where the branch per feature said, okay, these people published some book on CI/CD by Jez Humble and whoever else, and I was like, and at that point, I was already deep in Git and understanding how things worked. And I read this book. I'm like, oh my God, this is such garbage. How can anyone take this? And it was because it was by the Agile community accepted. It was like just sprayed all over the world. I'm like, oh my God, just like we think in event sourcing, like these CRUD people are talking about this, that, and the other, or like, just face palming. This is so stupid. I had the same reaction with the CI/CD book. It's like, oh my God, 10 steps backwards for like what Torvalds did. And you have all of these, like, there's a reason you don't have trunk-based development on the kernel. Or, there's a way to do continuous integration without publishing code that's not ready. The feature toggles were like, this is a nightmare. And finally, when I found the Knight Capital paper, I'm like, okay, this is why you shouldn't have toggles or these live config stuff. Because for those that don't know, Knight Capital went bankrupt in 45 minutes after a feature toggle was mistakenly published, and code that wasn't supposed to ran in production. And the code that ran was an anti-feature to simulate what a bad system would do, which was buy high, sell low. Well, when that happens 1,000 times a second, you go bankrupt. I mean, their entire account was drained from that one misconfiguration. So that's why, it's a good story to understand why you don't want things that are not ready to be in production. And so my idea was always to see how things worked before. Well, how did Linus Torvalds, take so many different proposed systems and test them and have, branches not live in isolation for so long that the environment underneath has changed so much that when it comes time to merge, it's a nightmare, giant, all or nothing merge with a ton of conflicts that you can't, go out and do. But I had a better way of thinking about systems, period, because I was already doing event sourcing at that point. So I saw the level of modularity that was needed, right? And it's a lot harder to do that with CRUD and traditional systems to achieve that level of modularity that we kind of get with event sourcing by default. So that already, I had the answer in my head. I had the how. I didn't connect like the whys and the whats yet. But
Yeah.
once I did, it was I can have this. I can have my branch, but I can make another branch called integration, where I'm not going to publish from there, but it'll give me the feedback for continuous integration. I'm not publishing it, but I know as my branch lives on that I'm veering away or not. Not only that, but I'm also capturing all of the merge conflict resolutions along the way. And if I have re turned on, the remember resolved resolution thing, right?
Nobody knows this feature in Git.
I know, but I mean, even if you don't, if re didn't exist in Git, which is remembering how a file conflict was resolved. It's a great feature, by the way. Most people don't.
It is. I use it all the time.
Yeah, but even if you didn't, Martin, you could go look into that integration branch, which never gets published, and you could examine every single merge and how you resolve the conflicts in those merges to understand how you do the same thing when it was time to publish that branch to go public. So I think we discussed this on a past episode that you're fine with production level toggles and all that. That's fine. And it boils down to where you're going to have that go live done. Is it going to be in code or infrastructure code? I choose the infrastructure code. You chose the in code.
Yeah.
And I think we have a safety net of event sourcing that doesn't really matter as much. But I want something that will transcend just event sourcing to all the other things like incidental code that you might have in some other pieces of the system that may not be event sourced. And there are some, right? Like there are places where event sourcing doesn't make sense, like a algorithm heavy thing, that information systems, we can say by default, should be event sourced. Anything like a insurance company or point of sale system or any of the 99% of the systems out there in the world, but by default should be event sourced. But then you have some things that are very niche or very highly technical or something, and that's where I think this idea of keeping things out of production makes sense, because at that point, I would not want to have a feature toggle in the middle of a complex algorithm for search.
I saw this. I saw this happens. But
that's a nightmare, because what happens there? Feature toggles work if you have consistency, right? And this is something that CRUD struggles with, because you have an application of like 50 different patterns you can do to solve anything. In event sourcing, you have 2 patterns. Really, it's the input and output. It's all projections, and the projections are always done the same way. So when you find a feature toggle in an event source systems, it'll look identical to every other one. They claim that in traditional systems, if you're really good, you can make these feature toggles look really the same across everything. You have a pretty good, absolute baloney, because you're employing any number of what's it called, the 50 standard patterns out there of observer, of factory. I don't know. There's so many, right? You're doing software properly and observing all of these patterns to make sure you implement that. So you probably have an implementation of associated feature toggles, like maybe feature different, equal amount of feature toggle types that you'd have to implement. And so now you have to be an expert in recognizing 50 patterns, and not only that, but also ad hoc code, because there can be developers that don't say, I don't know these patterns. This code will work, and they'll do something that's custom, which is fine. But now you have to, again, put on your thinking hat. Okay, how does is this feature toggle okay? Do I have, the whole thing encapsulated correctly? Is there going to be a leak of this logic somehow? If, it's this kind of stuff it's very hard to digest. It's constant friction as you're going through. It's another worry, right? You don't want to be walking on eggshells as you're developing. And if you only have, 2 patterns that you're using throughout your solution, slice by slice, any anomaly jumps out at you. Whereas if you're looking at 50 patterns, you'd have to spend 50 times as much effort and experience with that solution to get that same feeling. And so that's delayed much longer, and that's why you have these long ramp up times and all that. Anyway, a lot of brain dump here. So what are your thoughts on all of this? Your turn to do a brain dump.
Oh, I have a long history with feature toggles, and I really hate these feature toggles in code. This is really these if statements scattered everywhere, and you cannot get rid of them because they are everywhere. And if you want to get rid of a feature toggle, you first have to look everywhere in the code base. Where is it? It's horrible. So my feature toggles, we discussed that. My feature toggles in code are by slice. So there is one toggle. You can put an annotation on a slice, and either it's enabled or it's disabled. That's all I have. There's nothing else. Using that on slices, perfect. I'm perfectly fine with this. I also like your approach doing this in the infrastructure. It's also fine. But putting the if statements in code is nothing. I will never, ever do that. And this is really the most horrible way how you can implement feature toggles, if you ask me.
Yeah. Yet this book that taught people to do this is said that this is the epitome of CI/CD. It's like the Bible. It's like, oh my God. So these are signs of how dysfunctional the industry is, when you can logically prove how things are very bad for your solution.
Yeah.
And yet it's what's taught by default. It's very frustrating. And I said this before, I wouldn't be in this industry if I couldn't prove that the proper approach works and is better. And it's one of those reasons that I did the fixed cost thing, because if anything is worth its salt, it's going to be something where you put your money where your mouth is and you say, I'm so sure of this approach that if there's any problem with it, I will fix it for free, and I will have everyone else fixing it for free, and I'll have them agree to do that and agree to those terms. And that is, I think, the biggest contribution that myself and Adaptec has done over the last 10 years, is to basically say, yeah, go for it. Throw us your giant point of sale system at us, throw us your large insurance company, make it worth 8 figures of budget, tens of millions of dollars. And we don't even have a legal department. We stand behind that statement of we'll do this for fixed cost, fixed price per slice, and we'll fix any defects for free. And it's been without...
You don't put any time limit on that, right? Even after 10 years. If somebody comes after 10 years, you will fix it, right?
Nope. Absolutely. Yeah. That's the thing. I mean, legally, we should probably say 2 years, just not to look silly, but there's also a 2-year limit naturally in most law that you're out of what's the word, the legal term? Statute of limitations, I think it's called. Like some things like murder, you can be tried for forever, but like regular law for like for example, in your I don't know if you have at least in North America, if you have like fees for your apartment, like if you own an apartment, and you don't pay your fees, they can't come after you after 2 years, or something like that. So the statute of limitations, I think tax law is 7 years for collecting taxes or something like that. So, if you're saying that I'm going to fix bugs for free forever, yeah, sure. And I mean, I'm not going to be a jerk about it if it's like 3 years on and you're like, hey, we have this bug in one of these slices. Like, yeah, sure, I'll fix it after 3, 4, 5 years. And the only reason that I say that is because I know that, these systems are so predictable that these bugs, we know from our experience, don't take longer than, for us, 4 hours to fix, deploy, and everything. And they're so predictable that even coming back to a system 5 years later, I'm not scratching my head trying to decipher what the heck is the solution. It's done the same way. It's all by slice. It's all event handlers, all over the place. And with the given when-thens right there, we know exactly how, each slice is supposed to behave. And in those systems, we can always look at the live data, the events from the live system, and isolate what they're talking about and say, oh yeah, this is what happened here. Sure, that's a legitimate bug. And sometimes maybe this feature, sorry, this request for fixing a bug is actually not. It might we go back to the event model before we touch anything and say, okay, let's see where this bug is on the event
Yeah.
model. And we take what the client says and I say, oh, it's supposed to do this. It's like, well, the event model shows the correct behavior. So, to be honest with you, you probably forgot that you didn't specify this.
Yeah.
And
Maybe
you
it's a requirement.
actually want a different slice here.
Yeah.
Let's review this together. And they say, oh, right, sorry, it's our fault. We never got this implemented, and so yeah, we go ahead and do that. And so we actually get more work that way, because
Yeah.
sometimes a bug report is a feature they thought they asked for, but they didn't. And that's fine. That's just how some businesses are. They keep going fast or whatever. But yeah, so yeah,
I mean, isn't that is one of the that is so beautiful. I mean, try that with a Jira ticket.
yeah,
Oh, you didn't specify this correctly. Oh no, this is a bug. No, this is not a bug. And then you go on discussing this forever. The event model is
it's
pretty clear.
horrible.
Either it's modeled or it's not. There is no there. It's black and white.
Yeah, I mean, there was a post that someone wrote on LinkedIn. Actually, I was reading it today about how the English language cannot be a programming language because there's too many anomalies. But
I'm
it's
saying
like,
this all the time. Yeah.
yeah, it's I forget who wrote it. It's one of the more popular people on LinkedIn that is kind of a fan of event modeling, but they haven't had the opportunity to jump into event sourcing. Um, so it's kind of funny to see this from them, because they're like on the verge of making the leap to say that, well, we have something that's right in the middle. It's not the English language for specifications, but we have the event model that is using the natural language to express things, but it has guide rails and constraints to be
Yeah.
able to act like a programming language, but it's a lot more digestible by everyone. You're not going to get your business person to read Python because Python's the most beautiful language. They still won't do it.
No.
But an event
No.
model, they will, because it has things they understand. It has, these wireframes, so they understand the context of like, oh, hey, I'm on the screen, I'm trying to do this. The workflows are labeled. Hey, I'm signing up for the service, or I'm checking out. I have my basket and I'm checking out and paying. They understand the context. They understand what screens are happening at this time for each user, like what each user is seeing, and they see the data in without code, right? So you kind of strip away if statements and all that. The
Yeah.
given when thens are now done in a timeline format. So someone that's reading it, they say, "Oh, these things happened," and then I try to check out. Oh, but I get an error that my coupon code is incorrect. Oh, I understand what that means. Let's look at the
Yeah.
history of in this timeline. What happened? Oh, the coupon code is this. They entered this other one, but whatever. It's it's like a English, but
Yeah.
it has the constraints to be a programming language. So yeah, it's kind of a good topic for today. I didn't realize I read something that's quite topical.
Yeah.
But there's definitely people that are so convinced that English or natural spoken language is not good enough, and that's why AI doesn't work and all that. It's like,
Yeah. I'm saying that all the time. I said that just in a presentation last week. I said the only thing worse than written language is spoken language. These are the two worst things to talk about requirements.
yeah,
And it's true. Yeah.
they get very loose, right? Like
Yeah.
and they're right. I mean, the article is correct, saying that the natural language has too many points that are subject to interpretation. And so what event modeling does, it still allows you to use that language, but it puts down data points. You
Yeah.
can't express this unless you give me an example of what the inputs and outputs are going to be, but they're not going to be anything technical. They're just going to be you're going to tell me a story of what happens in each scenario. That's all you're going to do. And then I can analyze that and see, okay, it's ambiguous, or it's sometimes I've done this myself. We're not immune from this stuff at all, but you can make specifications that are at odds with one another. And the nice thing about a slice, though, at least, is that you see them immediately.
Yeah.
Sometimes these whack-a-mole bugs or specifications that are at odds. It's not really a bug, but sometimes you have specifications, especially in a very large organization. The specifications are saying the opposite of what a previous specification is. And
Yeah.
we mentioned this before, but but these can churn in a very slow, sometimes years time. So you don't realize that you're actually just doing code churn to make the accounting department happy. They're happy, but now you've got the customers upset. So, okay, so then people fix the stuff for the customers. And then next year you have the accounting department unhappy because those specifications make a lot of errors in that system. So, okay, next people come in, they fix the things for the accounting department. So that's the whack-a-mole bug, right? I kind of explain in English terms. It can be done on a more technical level where it's literal logic statements that are at odds with one another, and you're just in perpetuity going around and around because they're paradoxical, they cannot live together. So you're in an infinite loop fixing them.
Yeah. Okay. You know what is crazy? We are already 30 minutes into the podcast, and we didn't.
We kind of wanted these to be more free
agenda,
right? We have a couple of topics. One thing that we did say is we want to have something for people to take away as a practice, maybe something technical as well, right?
Yeah.
So we'll have to find something to talk about technically that's fun for people to think about. But it's nice to just be able to relate our other experiences to how they're relevant for event sourcing. And I think, it's no coincidence that both of us were big into Git and event sourcing.
Yeah, why do you think that is? It cannot be a coincidence, right?
No, it's not. And I think it's immutability. Like if you want to, okay, here's your technical subject for today's episode. That functional programming, right? Functional programmers should, be patting us on the back for promoting immutability and systems and pure functions and all that. The thing that was frustrating me in the industry was how hand wavy the stuff was in terms of going to enterprise development and this, requirements that on the surface looked formal because you had these use cases that had these like sections and it was all like written out. You had these reams of requirements that looked really good, but in essence they were crap. They were just really hard to parse. They could hide a lot of anomalies and things that didn't quite were too specific in places, were not specific in others. But because it looked so formal, especially the junior people, it would look like, well, this looks very official. It can't be wrong. And then you'd be sent off on a wild goose chase. While, hacking on a system as a kid, my Commodore 64 would tell me exactly if things worked or not. If I had this assembly code working or not, it was very mathematical. So I expected computing to be very certain and very engineering-like, and it wasn't. I was very disappointed, 25 years ago, 30 years ago, stepping into the world of enterprise software development of just how crappy things were. They looked official, the paychecks were good, but the experience was absolutely the opposite. It was horrible. It was like you got paid for suffering, not for having fun. And I got into computing for the joy of it, for being able to create and express solutions and all. That's what gave me, the motivation to keep going. That's what kept me excited about being in this industry, or just using computers. Forget about the industry. And so, that's so Git was one of those things where, I saw beacons of stability. Agile gave me the illusion of stability because I had, if the tests don't pass, I can't move forward. That's great. So I can only, I have a point of check in time. And later I found out that wasn't enough. And it had its own issues that are quite significant, but I always kept exploring through that, and especially BDD as well, because it was like, okay, stories are good. I can see how this logically will make my sort of need for some good requirements and good points in the specifications that are logical, that can hang on to and use as an anchor for confidence to move forward, right? So that's all I was looking for, is these points of confidence to move and build on. And so Git did that, because you can't argue with the history. It's content based addressing. So what that means for people that don't understand, there's no way to mutate a Git history without changing the hash values in the rest of the tree forward, right? That is immutability. To me, that spoke, oh my God, that has the biggest problem with source code, source control solutions solved in the simplest way possible, where you have one function that does it across everything. It doesn't require a giant database and all this other stuff that all these other systems were trying to do. It solved what TFS and all these other systems wanted to do in a very simple, effective, performant, scalable manner. That was just brilliant. Content-based addressing, and it solved the distribution for the large sizes. So I think that, along with event sourcing, I kind of came to both of those at the same time, but they really were based around this immutability piece, where I knew, like in event sourcing, the beautiful thing is that I know that all the actions that people have taken with the system and pressed buttons and added data is that I have a full account of that. And no matter what my future requirements for features are, I have a solid base. Like, I can't argue with that. These are the things that are sitting in production as inputs of data in their raw format. So there's nothing that I can face that scares me, that is ambiguous or anything like that. So, and same with the Git history. There's nothing that scares me about future changes, because I know that if I have this branch with this particular hash value, that it's either there or not. It's an immediate answer. I'm not saying, oh, it might have something else in its history. I know that if I have that hash value, I'm always going to have that set of merges, set of commits in its history. There's nothing that can change that for me. And so I think it's this stability that kind of echoes a lot of real engineering practices out there. I say real engineering, as software engineering isn't real to me because of some of the hand wavy stuff that we have. The large lack of design from agile efforts over the last 20 years have really done a disservice, I think, to making software engineering not engineering. Maybe on a meta level, hey, I'm engineering the process of going through TDD and all that. Fine. Okay, you can call that some sort of a meta level, higher level engineering because you're disciplined about red-green refactor. But the solution itself isn't engineered in my eyes. At the fundamental, like, core level of what you're developing, it's far from how you build a car, how you build a bridge, how you do that. And I don't accept the argument that, hey, these are flipping bits and over there you're putting bricks, so things are harder to undo. You're still spending time in software, and so it still costs. So I don't buy the, we're not building bridges here. And that the old agile kind of way of trying to sell, the red-green refactor cycle, the daily stand-ups, all of this stuff that we dropped long ago, that doesn't hold the same guarantees as design. Yeah. So anyway, what are your thoughts? How did you arrive at both? Why do you think Git and event sourcing and event modeling all kind of, like, why is that a common thing in our histories?
What always attracted me was simplicity. Always. If I find a system that solves the problem and it is simple, I was always attracted to that. And Git is exactly that. Git is super simple. And what I found fascinating, I remember this very well, when I first understood how Git worked, how easy it was to really look at the implementation, you could even look into the Git database. You could just open this .git folder and look into, is this file there or not? You could really just step by step go through it and see, I know exactly how this thing works. Exactly. I know where the branches are. I know exactly what happens. And if something goes wrong, I know exactly where to look. And if this is not there, I know this is the problem. This always attracted me. And the same for event modeling. When I remember very well, when I read the article and I understood what that means, what attracted me was the simplicity. Hey, wait a second. No matter how complicated the system is, if we break it down into slices, I can just go start on the left and go through the whole system until I arrive on the right, and I know exactly what happens. Yeah. It's the same. It's about simplicity. And the same for event sourcing. Yeah. Same thing. 2 patterns applied over and over again. The code is boring as hell, and exactly this is what it needs to be.
Yeah. Yeah. One of the nice things about the simplicity of Git and why I kept going down that path is to learn Git. You could open up a new repository, make some changes, do some commits, make some more changes, do some commits, branch, make some changes on the branch, make some changes on the other branch, merge the two branches. But in between each step, you can take a backup of the whole directory structure and then do a diff. And in that Git folder, the difference is, oh, it created an object. Oh, it's got only 4 objects. It has 4 fundamental objects that it's using to do all of this stuff, right? And so, those are the first steps I had with Git, is just going like, oh my God, this is, like you said, incredibly simple. Like when I made this commit or this merge, all it did was create, how does it know which 2 branches merge, which parts of history got merged? Oh, look, this commit thing has a place for the hash of the last part of the current branch, and it has a hash for the one it merged with. Oh, wow, that's cool. Oh, I can do more than 2 branches for a merge. I can have 3 and 4. Oh, that's an octopus merge. That's how it works. Okay, so let's try it. Let's do a difference between the folders structure on the file level, and that's amazing. So it was the simplicity. Also, now if you look at it, it's like a bunch of hash values and you have to look what's inside the file. So like, maybe if you're new to programming, it might seem like a little bit too complicated, but with a very little effort, and once you understand how a commit object is created, or how a tree object is created, how it's structured, and how a blob object, the actual contents of a file, is encoded, and a signed tag. I think signed tags are the only some people say it's 3 core objects, some people say it's 4, but the only way a tag ends up being in the object directory is if it's signed, but otherwise tags and branches are kind of superfluous to the core history. But even then, that's another subdirectory in the .git folder, right? It's sitting there as like, well, here are your references. They're, this is one of the reasons that I push for creating event sourcing solutions that are not based on databases. And I'm pushing this further with DCB and having indexes that you write yourself, because I see indexes, especially in event sourcing, as being as simple as Git histories. They can have the same guarantees. And you might have to rewrite some of them, but the problem space is contained. Like the scope is so nice and small. And the beauty of event sourcing is that, you can have these, it's not one giant model that's super complicated that you have to coordinate everything on. It's about having those small individual models that you have a finite set of problems to solve, and you can solve them within a reasonable amount of time. And not only that, but once you learn all of the patterns that you've done for one model, you can apply that to subsequent ones, right? Maybe you can share parts of the index tree with other read models. And because it's immutable, it has that structure that I'm always going to be using this. It's fine to share, right? We talked about dry principles, and like still lots of people online arguing about, dry is really good. And that's actually a good topic to cover. But anyway, this idea that, this simplicity, you can just keep going with this. And it's why I think a file-based solution, you can have an enterprise level giant system, like an insurance company, without using a database, all being file-based, having the simplest web framework, Node Express or something to show websites and web pages, and to actually scale it. The idea that you can have redundancy on 3, 5, 7 nodes, and your index is just files. You can do that, and you'll get like a file count that's too great. And how you do that is how Git solved it too, by the way. How does Git solve too many objects?
You mean the folder structure, or what do you mean?
Like if you have, so it becomes inefficient after you get a large enough history that there's just so many object files that it's inefficient for the system. Yeah, pack files, exactly. Because you know Git. So what's the equivalent of a pack file when you're making an index? It's a lot harder with a very complex database, But it's a lot easier if your index is based on events, which are forward only. You could have brand new pack files of subsets of the index based on your usage and needs and how often you're re-indexing stuff. So you don't really have the same issues as you have with trying to make, this global model. So I deeply think that we can do incredibly large systems without any vendor help, especially in the age of AI. Because if I want to make an index, I can ask, hey, make me a B tree. I can start to at least get the seed idea so that I don't have to go through the Wikipedia articles of looking at all these different tree structures. I can start experimenting right away, much more quickly than I could 5 years ago. Because, were we writing B trees 5 years ago when we were consulting for clients?
No.
Never, right?
I did it at university, but professionally, no.
Yeah, because who would want? Hey, Martin, why are you spending time learning this geeky stuff? We need this website to work. What are you doing? Right? Yeah. there was that imbalance of time. You just, based on what the user needs were, you couldn't afford to spend your time to figure out how this deeper level works. But now we do, and I think it's a big warning sign to a lot of large companies. Like Oracle, especially, that's the greediest, largest database company out there. And the writing's on the wall, if they don't shift as they're doing into AI infrastructure, that their database business will be toast. I believe that. I think there'll be at least new business. They'll probably have a whole bunch of, legacy stuff or existing systems, or maybe they'll come up with new products to sell. But as it stands, what the business model is and the heaviness of it, I don't think it'll, at least for good companies, I don't think it'll go be relevant, right? I mean, are you thinking of Oracle installs for any brand new startup?
Startup?
I'm not.
I don't think so. I mean, I had a few startups who thought about Oracle and they wanted to use Golden Gate, but that was just ideas until they saw the price tag, and then it was off the table immediately.
So, but I don't want to kick them at all. I mean, they have a business. They have customers that are willing to pay for what they offer. Fair enough. I'm just saying that there's other options, and I think the choice of options and the feasibility of options is going to change very, very fast. The amount of stuff. I mean, look how fast you're going with all the features that you're putting in. I'm looking at all these nice features coming into the Miro add-in that you've made, and it's like there's no effort at all. When I see, someone needs to rename fields across all the events, next day, that feature is implemented. That's
because it's sliced.
Yeah, exactly. Well, a little cheat code here, of course, because we're talking about event sourcing. But even if you needed to say, well, there's this new UI thing that you have to incorporate, that you're not spending 2 hours on Stack Overflow to understand how that piece of React works. You're pretty much done in 5 minutes. That's the beauty, right? So even if we're working on slices, the problems we're solving within slices because of AI are doing that. And my greater sort of message, I think, is that the infrastructure for event source systems is becoming trivial. As you do this, you solve one indexing problem for one slice, you can use that solution on how you're going to solve all these other ones, or at least the starting point. You're not starting from zero on all the other ones.
I agree. Yeah, definitely.
So anyway, that was a fun segue. But for those binge watchers, you're getting some insights as to where we came from, and hopefully you find similar kind of hooks that excite you in the industry, and that you can grab on, like Martin grabbed onto Git, and so did I, because it had this beauty about it. And you'll find the beauty in things that'll keep you motivated and keep you going. So, and I think AI is opening up a whole bunch of other opportunities, other avenues that were off the table before. Like indexing for me is awesome. That's my next new thing.
Nice. Yeah. I mean, in my opinion, you should always have one thing that drives you. I always had one thing. It was, at some point it was Git, then it was the Spring framework, then it was event modeling, then it was event sourcing. There was always one thing that drives me. Every developer, every person should have one thing that you really focus on. And I think you can really get easily to the top 20% of the world if you go deep. And if you go a little bit deeper, easy the top 10% of the world and more. So it's easy to get really, really a good expert in a topic if you invest a little bit of time.
Yeah,
And you should do that.
absolutely. I can second that. I mean, my Git investment I was floored to see, the placement. I didn't think I'd be in the top 500,000 on Stack Overflow, but I ended up in the top 1,000, which was great. And then I looked they actually follow how many people are looking at your answers. And I was in the top one, less than the top 10th percent of all contributors. I'm like, well, holy smokes. And like 20, I think it's like 20 million users looking at my answers already. Like, holy smokes,
Amazing.
that's a lot. And I never expected that. I was using it selfishly to learn, but because I was teaching, I chose to learn by teaching others.
Yeah.
Then it sort of made this incredible ecosystem of knowledge transfer. So yeah, that's a good sort of story for people that are maybe people are a little bit dismayed and disillusioned with AI, that their jobs are going to be taken and things like that, right? I think the last episode that we have is that AI is taking your job. Yeah, but it's taking the crappy one you don't want to do anymore.
Yeah, exactly.
The job it's taking is the scouring of Stack Overflow and Wikipedia articles for 2 hours before you start writing the code you need to write. That's the crappy job it's taking. So.
Yeah. But when was the last time you were in Stack Overflow? Actually, I didn't use it in the last year.
I can't remember. It must have been just by accident, probably some search for something. I'm thinking. You know what? Also, I'm finding really weird, and I'm not sure if that's Stack Overflow using its legal department, but you know how when you ask Grok or Cursor or Gemini or any of these coding helpers or just general LLMs, it shows you like what sources it's searching for, and it'll show like it's getting this from Reddit, it's getting this from Wikipedia, it's getting this from whatever, and it's analyzing it and then it's giving you the answer, or at least going into further steps.
Yeah.
I don't think I've seen Stack Overflow in any of those sightings.
Maybe
that is such a shame. Because I think early on with ChatGPT, there was a big kind of moment of like, hey, you can't be stealing our answers. You can't be crawling our web pages to feed your...
But that's what happened. I'm pretty sure Stack Overflow was one of the biggest sources to train the first ChatGPT.
Well, they did, but then they said you can't do that anymore. Yeah. And it's actually sad because I think Stack Overflow has a tremendous amount of information in it. The nice thing about Stack Overflow is it is sort of event sourced because, like I said, I edit my answers to improve them, even on the very first get-go. And at least I did when I used it. But so that gives you the temporal aspect to information, right? You have a history of who answered a question in a certain way. You have revisions as a very popular answer that got promoted to be pinned for a topic. You have a whole revision history of how that answer evolved as the technology evolved around it. Nice. And wow, what a great source of training data for people to be able to use that. And I don't see anyone putting AI investment money into Stack Overflow to kill ChatGPT or any of these other ones, because for programming, it would be fantastic. I think what's happening is that these are being done in secret. They're being anonymized. They're anonymizing the data enough so that Stack Overflow people can't prove that it's been trained on their data or something. That's just speculation. I don't know if that's true or not, but I'm thinking like, that's a fair amount of training data there. I mean, it's probably one of the best sources for, showing the evolution of how something got argued about, especially when you have a difference of opinion, when you have different votes on different answers. One, especially like if we talk about trunk-based development versus feature branching, right? That I would have in an answer, you would have both of our opinions in there,
Yeah.
and you could see the difference. AI could learn that there's a fork in the road. You either go down the blue pill and stay in the matrix, or you take the red pill and see that feature branches can be continuously integrated. And but it shows you both thought processes behind them, and it could answer very, very intelligently by analyzing the discussions on Stack Overflow. Not only do you have the revision history, but you also have, for each answer, you have a comment history, right? And links to other articles. So
All you need.
think about the vector database power that would generate. So I don't know. I mean, maybe something's happening with Stack Overflow where they're making a deal with Anthropic or something behind closed doors, and they're going to walk out billionaires because of it, or trillionaires these days. Elon Musk just got $1 trillion approval pay package, which is crazy.
Yeah. I think even the Pope said that's not a good idea. But
yeah, I don't think who needs that amount of money. But I mean, I don't want to get into politics or business stuff here, but I mean, I'm kind of worried for Tesla people, because it's a car company that he used to launch his own ideas, and now if he gets $1 trillion payout package, it's kind of like there better be some really good legal documentation in there, because he could take that $1 trillion to make a competitor, sell off Tesla, do something else entirely with it, right? So who knows? $1 trillion is a lot of money that you could pull off a whole bunch of stuff, right?
So personally, I don't know why. Well, let's not get into this, but I think it's bound to a lot of things that need to happen so he gets the $1 trillion. It's not a walk in the park, but
yeah,
I still
probably.
don't know why does it have to be $1 trillion? That's just
no. I know who needs that money. So I honestly don't think he wants the money personally. I think he can do whatever the hell he wants with the billions that he has. But I think it's a power thing to be able to create other entities and all that. It's not for him personally.
I mean, it would boost his ownership to 25% or something, which is a lot. You can do a lot with 25% ownership.
Yeah, exactly. But also that money can be done like for SpaceX or Starlink or all these other things that he has to grease the wheels for other deals, or whatever, buy out other competitors. Like there's a whole bunch of stuff. And I think in the age of AI, that multiplier, like Allard said, right, in his keynote, the multiplier for AI is huge. So where, a few years ago it was billions of dollars for these companies to buy each other out. He bought Twitter for so many billions of dollars. Now you look at his payout package as $1 trillion. Twitter looks like a rounding error for being able to buy that out.
I can very well remember. Was it Apple who first hit $1 trillion in valuation? I think it was Apple.
So. I think so.
And I remember this very well. Oh wow, they hit $1 trillion, and now crazy.
Yeah, now we had Nvidia hit five trillion, and now we have Elon Musk getting a buyout package for $1 trillion. So it seems like
he gets Apple 10 years ago as a buyout package. Really? That's crazy, but kind of funny. Why
it is. It is. I'm actually excited about this because not that I care. I don't particularly care for the guy, but the fact that these values are being exchanged shows how much better the industry is with the accessibility to information, right? Like we talked about what AI is unlocking on the last podcast about advancements in medicine and all that. How we're not going to have jobs, but that's good. We'll have time to take care of things that are important. So I don't think, if you look at this AI is taking our jobs argument from 120 years ago, it's like, oh no, working standards are taking away jobs from kids in the factory. Like no one wants to work in the coal mine. No one wants to work on an assembly line, getting just dying every day slowly because you're 8 hours of basically unrelenting, punishing labor with your back going and all that. No one wants to go backwards. I think, moving forward is good. And you got to keep the people in check that have a lot of power. that's why we have laws and we have regulations. And I think you just keep evolving those and make sure that, people are good to each other while we all can help more people. I think we
Yeah.
can. Event sourcing is a good big part of that. I think people don't realize how much of the AI movement can be harnessed in a much more efficient and better way with this immutable storage. Like even just looking at what I said with the history
Yeah.
of uh, uh, the Stack Overflow answers and discussions. That in itself is sort of event sourced because they were very good at, for accountability reasons, because you can't just change your answer with to be correct all of a sudden. People can click on the history of your answer and say, oh, they answered it this way, this way. These are the edits, right? And then once you get promoted to a certain level, you can edit other people's answers to correct them, right? So I know that at a certain point in my Stack Overflow engagement, they said, oh, now you have these, you unlock this, you unlock this. So now you can promote answers, or you can change answers, you can reject answers. So you start to get more and more privilege, right? Now with AI, of course, there'll be agents that would do that. So it could totally be gamed. But back in the day before that, it was kind of a good system. And so it captures quite a good significant chunk of history. And event sourcing is based on those principles at the core. And so when people start using AI, the 15% that are, I laugh at that article that 85% of participating companies had no real efficiency increases because of AI.
Yeah.
It's like, oh my gosh, it's that same. I think we mentioned this before, but it's that I saw another example of this where like people are what I said in the last episode was people criticizing websites in 1996. Oh, look how crappy the McDonald's website is, or like the Amazon website in 97 or 98. It's like, oh, it's such garbage. It's just selling books. It looks ugly. And it's like the technology was new. No one could have predicted that Amazon would have AWS and all that. And so it's the same kind of thing. Criticizing, any of the AI big names like NVIDIA. I think I wrote recently that people that are criticizing NVIDIA being like overvalued or something, it's the same thing as criticizing Cisco in 1997. It's like these guys are like not needed. We don't need that many routers and all that. And it's like it was at the very beginning of a huge uptick in creating infrastructure for a lot of the internet. And that's the same thing that's happening with NVIDIA right now. And I mean, from the investment side, you didn't even know that Amazon was going to monetize its own infrastructure to make AWS, right? Think about what companies like Palantir or any of these other AI names out there are going to be able to monetize. Like Google, for example, they have just last week released a thing that it doesn't have to be serial, like the token stuff. They're doing things in parallel now, so they're getting like the window. Like imagine your event sourcing window, and you can only get the previous event and process that. Well, mathematically, you could take a snapshot of more than one event. You could do multiple if you find the mathematical way to predict the calculations. So now Google's done that. So they're getting insane throughput and all that. And even during this whole time, we have, I think Microsoft was saying they have so many GPUs that they purchased that they can't even power them. The electricity is too expensive for them to even turn on like 80% of the GPUs they bought.
Yeah.
It's just crazy. So anyway, it's an exciting world, and I kind of say all this to reiterate Allard's keynote where this multiplier for the next move from, I don't know what the last one was. I guess it's cloud, virtualized everything. Everything's not your own. It's a service somewhere that someone's giving you. That somehow gave us a bit of efficiency. I totally agree with them. It's like 100 to 1,000 times efficiency for how we can do that. And I think we also had Felix, the guy, the PewDiePie, have a video recently where he had his 10 GPU rig, all open source stuff. So he has his own models running, but for $20,000, he has something that beats the performance of any of these online large language models, and he's generating anything. He's donating these GPUs to do a protein folding for medical research, which is great. So when he's not using it, 99% of the time, it's helping speed up finding cures for diseases and like Alzheimer's and all this. So it's really, really cool. People should probably watch that as well. Maybe I'll put a clip in of what he's done. But that's really exciting. And he's been able to do this because of AI. I mean, he looks up how to, put together 10 GPUs so that they all work together. At some AI questions that he had that told him the answer how to do it, and he did it. It's like, it's now the thing is evolving itself, right? It's a robot army starting. Soon will be removed as the part in the middle.
Maybe. Who knows?
We're the inefficient part. So then we had like, let's get on to a couple of topics that
we are already over an hour. How about these topics just for next episode?
Let's do one. Let's just say, why are slices necessary? So Sebastian said that, why are you drawing these rectangles? What do you want to say about that?
I mean, I really, so the argument was, why are you even drawing these rectangles? You could just look at the event model and you see exactly what happens, and you could derive from that what belongs into a slice and what doesn't. I personally, I like things to be simple. I want to look at the event model and I want to know exactly, okay, what is in this slice? So I draw the slice around the read model and the screen. So I know, okay, this part of the screen is in my slice. These given bandants belong to this slice. And there's just one slice after the other. I like things to be simple, and this is why I draw them. I don't want to look at the event model and always have to think, okay, what is part of this slice? Does this belong to the slice? Does this belong to the slice? No, I simply want to see it. Very simple. That's why I draw them.
Yeah. We also, once you get into working with more people and using the event model to track a project. So we use event modeling for cradle to grave, the whole software development lifecycle. Everything is on the event model, including progress tracking and all that. And so the vertical slice gives you, like you said, the scope of what's included in the work that needs to be done, which includes the UI at the top, includes all your business logic underneath, and of course, the persistence is a no-brainer. It's just event sourcing. So how you store the event, which is sometimes might have an opinion of actually which service that's getting deployed to and where it gets stored, because where the events live tells you where the service exists, right? So that's kind of the idea. But because we're replacing Jira and everything else, we want to show to the customer, yes, technically I know that everything can be kind of attached to, like, let's say the command handler, and everything related to it is the slice. So why do I draw that?
Exactly.
Well, it's also for clients that need to understand what's been built or not. And the client doesn't know that the screen is part of the slice or not. So by having the rectangle drawn around the screen, the command handler, and what gets stored, for example, or vice versa, you have the screen and where that information came from, what read model it came from, if you're doing a state view slice. A client sees that, and in our case, they see that, oh, hey, Tim is working on this slice right now. It's highlighted in yellow, and it involves the screen that I have questions about. And so that's why we use slices, is because it gives a very good visual for, what's going on in the project at any particular time, who's working on stuff. We can, at times before, we have divided the slice because someone was better at the UI. We stopped doing that. It's just complicated things. I think we covered it on a previous episode. But yeah, it's basically a really good visual for the scope of work, and not just for the developer, but for everyone. I think when we look at, internally, I'll say this to validate Sebastian's argument, is that internally, when we have to develop something with very little interaction with the client for whatever reason, and we have to go fast, we don't even draw arrows. Like, our event models are very much sequences of events, blue and green dots here, and a smattering of the example UI, because we've done hundreds of the projects. So we know by convention what's connected to what, and we can go very, very quickly without that. Yeah. Now, that's going to change with the tooling, where that's autofilled for you. So you can concentrate on just writing down the events, and either AI or something else is going to fill in the other parts, so it's complete, looks complete. But yeah, it's a valid point by Sebastian, that if you're looking at it from a technical perspective, there's no reason to do that. But I do it for clients for sure, because they need to know, like you said, like what UI work is going into this. How is my customer going to see our system? Are the developers doing this right now? Can I show them this part? Also, down below in the slice, this is how the data is getting stored. Am I missing information in there? Do I want more? Should I talk to the developers about that? So to me, that vertical rectangle serves many purposes, and it's valid. Yes, you can do without, no problem. You don't have to. But we find that it helps a lot for everyone to understand what's being worked on.
Yeah. And I can tell you there's nothing more satisfying than starting with a slice and then just going slice by slice and making one after the other green. I did that this morning. So I have currently I'm working on a project where there's a little bit of time pressure. So I have to work a little bit on Sundays. This morning I put on headphones. I put on Brain FM, which is like focus music. And I just started implementing one slice after the other. I really hacked them in, and I think it was 12 slices or something I had this morning. One after the other. And they are all green now. Nothing more satisfying than that.
Yeah. So it goes to that, being in the zone, programming, and having small enough scope to not get sidetracked, to keep going. And that's another thing, like that thread, it's part of information completeness, because what you're doing as you're doing slice to slice is that you're focusing on what is the next connection, what information is being brought over, what guarantees do I have from my previous work to start on this one. It's such a nice way, you think about, it's a good replacement for the Pomodoro technique. Instead of Pomodoros, do slices, right?
Yeah, indeed.
Like it's instead of having a time-based finish of, Pomodoros are half hours, right? You have like 25 minutes of work, 5 minutes of break, go to the bathroom or whatever. And then again, start your next half hour. And then you see, well, this feature took how many Pomodoros? It's like, once you get to the slices, it's like you replace your Pomodoro with slices. It's like, I've done this slice. I can go get a sandwich and take a 5-minute break, come back, next slice.
Yeah. I get in such a deep state of focus. My son said he was in my office 2 times. I didn't realize. I didn't see him. I was completely in the tunnel.
Yeah, that's amazing. So one last topic. Might as well just do a longer episode. Whatever. CRUD is doomed to fail. Is this who said this?
Oh, I said this today.
You were talking to someone though. I thought you were having a discussion with.
Oh no! Actually, no. This was a realization I had a while ago. No matter how strong you try to make your architecture, how much time you invest into your architecture, as long as you are based on tables and state-based systems, basically CRUD, you're doomed to fail. You cannot make it work long term. You always have to add new columns, and then you have these nullable columns. And long term, it won't work. You cannot make this maintainable over time. And I had this with the project I'm currently working on. I took this over from someone, and this was a perfect example. It was a CRUD-based system, and you had these nullable columns everywhere, because every feature was squeezed into a handful of columns, and you had nullable columns everywhere. Looking at the database schema, you couldn't tell what's going on here. Impossible.
My argument to that is I couldn't just make more tables that reference the old tables that are linked to the old tables to not have nullable.
Well, you can, but then you need to have you need to synchronize these tables. How do you do
Yeah,
that in a state-based system? It's not trivial. And if you need to replicate the information, you don't have the single source of truth. So it's really not trivial to make this work.
yeah. I
Um,
mean, I've been down that road myself many
yeah,
times because of having to work in systems. But one thing that event sourcing did teach me, even if I had to work the long way, is that I would find ways not to introduce a null. So I would make a table. It's like, hey, new feature. I'm not going to squeeze in an extra column. I'm going to make another table, and I'm going to make sure that there's only rows that exist for the records that are affected by this
yeah,
new feature. And so I got rid of the null. And I also got rid of a big problem of schema migration, is that I don't have that table that was originally there doesn't change its schema, and it's not getting more new information. I don't have to mutate that table any further. I mean, it's already
yeah.
bad, but I don't have to make it worse, at least, right? So there is you can do that, but you'll find yourself at a frustrated level like I did, where you can go even further, and so you end up in event sourcing world anyway. So how do you do this? You
I
know,
mean, what you do is basically you re-implement all the principles from event sourcing if you do it like that. And it's really not trivial, because if you add new tables, if you want your state, you need to join them. And the more
yeah,
tables you have, the more joins you need to make. So it doesn't get simpler. And
that's right.
this doesn't scale indefinitely. So long term, it
It
will
just
work.
it just becomes very unmanageable because now you
Yes,
have multiple different views, and like, oh, for this view I include this table, for this one I exclude this
exactly.
table, and then when does this one change? Does it change for this? Like
And then
event
I mean,
modeling can help with that. Like it can document that, but you have to use the event model as the place that is the source of the requirements. Um, but at that point, again, it's like you just might as well event source. It's
yeah.
like it's I don't
I
know
mean,
the
and just add the. I mean, what typically happens at that state is people come up with the wonderful idea. Okay, let's just use some database views. Views is like projections,
yeah,
right? Just let's use
sort
some
of, yeah,
database views and maybe some database triggers
yeah,
for replication of data, and suddenly
yeah,
you are in hell. It's absolute hell. It's the worst architectures I've ever worked on. It's
yeah.
absolutely
It's
crazy.
the other problem is that they're very hard to keep a consistent approach in because there's people that are going to be more apt to adding columns, or they'll have a good excuse to add a column or to embed more information into a field that already exists. I've seen that a lot. Just
Yeah.
add like implicit schema changes by saying, well, we'll just,
Even
you know what the worst one is WordPress. That's where like, hey, look at the WordPress tables. They're like document databases. Some of the fields just have JSON in there embedded with its own schema. It's like a rabbit hole. And you're like, oh, okay, that table doesn't have a value. It has a schema that has all sorts of names in it. And then, okay, so you go in there and you find a node in the JSON that is an encrypted or encoded other JSON for another
yeah.
add-in. So it's like this Russian doll of crazy abstractions. So going down that route is just begging for this kind of complexity. And I wouldn't give it the name accidental complexity. I think it's intentional complexity because you're intentionally rejecting something that works like event sourcing. So it's intentional complexity. We'll keep doing the thing that we know compounds the problem,
Yeah.
even though the solution is right next to us, and we just don't accept to do it that way. So, some people deserve the hell they create for themselves, unfortunately, because they reject something that's a clear answer that's simple.
I mean, I don't. So I don't say you can't do it. I mean, obviously, very very big systems have been built that way. But my argument is, you need to invest. The longer you work on these systems, the more time and budget you need to invest just to keep them
Oh
running.
yeah, they're very expensive to keep up.
Exactly.
There's a large government. I used this example before. large government or large institutions, I remember the budget for adding one field was $50,000.
I'm not surprised at all.
And yeah, exactly. And that, like, you just don't get that if you're doing event sourcing. So anyway,
Just compare that to my morning. One slice after the other,
yeah,
and if I want to get rid of a slice, I just delete it, and I don't think 1 second about what will I break with this, because I
yeah,
don't break anything with it.
yeah. I love that. I mean, the simplest thing I always say is, what happened at this point when you hit submit? I start an event, and then I don't worry about how it's going
I
to
don't
be
care.
used.
Yeah.
I don't have to go and jump into a giant mess of tables and how they're related, and figure out if I need to be worried about any of the joins being affected, or how this data is read by any of these other things. In
Yeah.
event sourcing, you know that up front. You don't need to worry about future features of how they're going to take that. You know that you've done the most responsible thing, which is write down what happened in that point in time. You're
Yes.
not trying to be a mind reader for future features. It's a statement of fact. This happened, and it can be interpreted in whatever way you want later. You're not constrained. So there's the big shift from CRUD to event sourcing for me is that freedom of, I'm changing state and I am not walking on eggshells. I am
Yeah.
fully happy to put that event down on disk and have it in the history, and I have zero concerns about future Adam having to worry about that.
Yeah.
Future Adam is not going to have a hard time.
Yeah.
He's going to be able to implement the further slices and look at, this nice event that happened, and I'll need to transform it to fit this new view that I want. But it's okay. I'm not lying to myself about this data being enough or not enough. It's exactly what the data was. It didn't have to be manipulated into or contorted into some other shape because of other features already working this way, or future features wanting to work a certain way. It's like that ability to just worry-free coding. Just keep going forward. No
Yeah.
worries, no walking on eggshells, none of that crap. So that's why it was easy to let go of TDD as well, because sure, we have unit tests, but do I really care about, having red green refactor? No, I don't. I might do it on a minute scale if that's the way I like to work, but I don't have to. Like, once that slice works, it's okay. My tests are more of a specification, really, about whether the slice is working or not. So
Yeah.
the CRUD system had TDD in it. I'd have to make sure the whole test suite runs, because I know that it's going to change this and that and the other. It's like, here, I'm not worried about that at all.
Yeah.
I'm just adding a new piece of information into the system, and if it's a new slice, it's new for everything. My previous read models aren't affected, so totally fine. And if they are, I know what the difference is. I have a
Exactly.
before and after view of, like, this existed before the event was there. Now it's with this one. I can update my specs, my tests, run them all. So yeah, I love this freedom. I know what you're going through, and this is one of the biggest biggest draws to event modeling and event sourcing, is just the freedom from being always looking over your shoulder for what your side effects are going to be. CRUD is filled with, like, CRUD is side effects on steroids.
Yeah.
Even if you have good architecture, even if you do all these things, you're still
It doesn't
always
matter.
looking over your shoulder. You're
Yeah.
always looking over your shoulder. Like, what did I do potentially? Do I have good test coverage? Is there something that's going to get,
But
triggered off somewhere else?
there will always be this one requirement that comes in. One requirement that completely destroys your whole architecture because nobody thought of that. Guess what? I'm not afraid of this. I'm absolutely not afraid of this in my
Yeah,
architectures. Whatever they throw at me, easy. No problem. In a
yeah,
CRUD system, no way. No way.
yeah,
If they throw a really bad requirement at you, it might break the whole architecture, and there's no
yeah.
way you recover. It's
Yeah,
really like
there's potential features that will force you to redo your entire schema,
but you can't do
or
this
chunks
easily.
of it. No,
You
that's what
can't
I'm
do this
saying.
easily.
I'm not saying you can. I'm agreeing with you. Like, yeah, it's one of these reasons that, like, yeah, the CRUD architecture, a possible future feature can like literally drop a bomb on you.
Yeah.
And it's the other problem is that it's so hard to articulate the impact of that. So you're hiding behind like extra large t-shirt sizes, and it gets into this like management machine churning and excuses at stand-ups and retrospectives about how that feature went. All that stuff just goes away. I'm just happy.
And I mean, yeah, you can go very long with that. I mean, you can hide the problems for very long, but if you have this feature that comes in, it makes a big crack into your architecture, and this typically is the start of the declining of your system. This is where everything goes down the drain. There's no way you recover. Everything just gets worse and worse.
Yeah, it's really hard to pivot your architecture in CRUD, right? Like you can't pivot your architecture because of that. Now with event sourcing, you have all your facts that happened in the past. If you have to have a brand new abstraction of how you interpret this because of this new feature, you're totally free to go to do that. You have a brand new projection off of that. Okay, we have to think about these events in this way. This data was missing. Now we have it from these new events. You have a very concise kind of way of moving from that. That's why I always say that your schema migrations are a non-issue, because you have to think of them at the time of each feature being added. You have to project your events in a different way right there and then. You're not waiting until the big bang next version release where you're going to have this giant, we have to migrate our production database to this new system that has this crazy feature.
Yeah, this has to happen on Saturday, and all the people have to be there.
Yeah, and so that's why I agree. That is why CRUD is doomed to fail, because you will have these features that will introduce a schema migration that will destroy your company.
Yeah. And you know what is really surprising? So I posted this article today on LinkedIn, and there are really people arguing about this. For me, it's obvious. It's obvious that this is true. It's a fact. And there's still people arguing about this. So I really don't understand this. What is there to argue? There's nothing to argue.
I know. I have the same argument this week with the dry thing. It's like, oh no, if you don't do dry, then like you're gonna have unmaintainable systems. And I was thinking, like, why do these people still think that? Like, and I think it goes back to the table schema, because people when they talk about dry, and it's been introduced long ago, but it's been kind of changed in its meaning with agile by meaning like code. Like, if you have two pieces of code that are doing the same thing or almost the same thing, smash them into one library so it's done. But you've actually coupled the work for those two different pieces. You've coupled the work, but that's not enough to explain it. I think what I realize is that people have this default approach of the giant canonical database underneath. So even though you have a class or something like that, or a function in your code, there's an equivalent entity in a table below.
Yeah.
So when they're talking about dry, they conveniently ignore the data that's stored on disk. That is actually part of the whole equation. So I see most of the dry arguments online talking about the code, and they entirely forget about state progression and the state of the system. And so you have to have this vertical slice way of thinking about this to really understand how, having dry as your, don't repeat yourself mantra, for how that actually increases coupling and how you hit a wall, because you're basically end up forcing a single abstraction to be good for 10 different objectives. And you're never going to have the best abstraction for all of them. You're always got, every single one is a shitty compromise, and you're just basically trying to build the least shitty compromise, which is not the way you should be working. You want a specific custom built projection or state for each way that you're going to tackle those 10 things, even though they look identical, because they aren't.
You just reiterated my whole article. Everything you just said is exactly what I wrote in my article today, and this is what people are arguing now.
It's one of my favorite Rick and Morty clips. It's the Anatomy Park episode, and it's not the actual episode. It's after the credits. It's the last little clip, 2-minute joke at the end that they put. And let's see if I can include it and not get demonetized. But it's basically where where his nice anatomy park, which is you get shrunk down to tiny and you can explore the organs of a human being inside of a cadaver that he has or whatever. But anyways, it's a funny episode. But in the end, he has a whole management system taking over his thing. And it's like, you're not, we're thinking about the Pirates of the Pancreas is not good or something like this for the amusement park ride in the body. And he says, well, you can't take that away from me. You're just building a shitty compromise. You're not building this. You're building a shitty compromise. It's one of the best quotes. Yeah. Nice. That's kind of like how I feel when I look at a traditional system with CRUD, and this dry principle that's kind of being hammered. Like you have to have the centralized control, because like if there's a bug in any of these features, you have like, one place to fix it, and that bug will be fixed in like all of them. The opposite side is that the bugs that you introduce or don't know affect everything, right? They're not isolated. So I always see it as you can't make everyone happy all the time. So you have, when you're doing dry, you actually are eventually making a really crappy compromise. And each of those points of your workflow that uses that common code is at an expense to each of their own integrity of how they work, because they have to make concessions for how the other part is going to work. And this one has to make concessions for how this one works. And so you're stuck in a shitty compromise. So multiple models address things perfectly for each piece of your workflow. And that's why we don't do dry. And in order to understand dry, it's not just code. You have to understand the table structure below and why that works against you.
Yep.
So anyway, that's a good place to end the episode. A very long episode, but so much fun to always catch up with you. So it's a sign of like we needed to do this again. Another season's going to be super fun.
It took us a full hour to just get to our schedule, right?
That's okay. So we got more announcements coming. Look online for this. We're not going to put, because I'm rejigging how I'm publishing the podcast. I'm going to try not to put any timely announcements into the podcast, but we are working on our own project. And for others that are concerned, you can be involved. It's not just me and Martin trying to have a monopoly on event modeling at all. This is going to be open source. It's going to have a place for all of the particular people that are in the event modeling space, especially event sourcing too. But we want to work with everyone. And so just because Martin or I didn't mention a specific project, don't think that you're not welcome. And so I'm going to try and avoid to talk about specific projects, because I know that other people feel they're left out. So I'm going to try to be very gentle around this. I want to make sure we support everyone that's doing event modeling projects, and the door is open. So always, when you hear something on the podcast and you're like, hey, what about that? Just message us and say, let's work together. Absolutely. The answer is yes. As long as you're wanting to work to progress event modeling forward and event sourcing forward, the door is always open. Maybe we won't agree on certain things, but there's probably a place for a module that takes your opinion and drives that module in the system. There's always a possibility to work things out together. This industry is filled with projects being forked to make other projects start and be the basis of that. And I'm totally open to people doing that to what we're doing. So, and I hope that it's not a fork. I hope that we can continue to just work on a module, basis of modules, etc. I think we're going to be doing that with some other people that are not doing event modeling as the core, but they want an event modeling view as a module. That I'm happy with the inverse too, right? So, yeah, and so there's lots of work coming up. Hopefully, more stuff with larger players like Axon IQ and others. I think I have something to talk with Current as well. They're doing new stuff, so door is open to everyone. This is not an exclusive club. We actually, I'm putting my own money to give things away for free. It's not really anything that I want to make money on. I want to. Like Martin, I think we share this, that we want everyone's experience to be as happy as what you did this morning of going slice to slice and just being super happy with the productivity.
Yeah.
That's a good footprint to leave on this earth, so that you made, that's how I feel about this, is that we're making a better environment for everyone to have a nice time, and have a good environment to work in, and produce and make things that are good for everyone. So anyway, just
That's
my
a
thought.
good,
Any
a
thoughts?
good
Any thoughts
closing.
on that, Martin?
Oh
Yourself?
no, no, that was a perfect closing. Let's keep it at that.
All right. Well, we'll see everyone next week. Thank you, Martin, for spending the extra time. I know it's getting late in your day. Enjoy the
No worries.
last couple of hours of your weekend, and we'll see each other online soon. All right.
All
Bye,
right. Take
everyone.
care. Bye bye.